Hello? Hello? There we go. That speaker's acting up. Cool. Why are you acting? Hey, Chris, can you come out here and fix the speaker? Or yell at it? Okay, so welcome to United Astronomy Clubs of New Jersey. We are here in Jenny Jump State Forest in Hope, New Jersey. Yeah, it's being problematic. Right. So while people are just finishing parking and hopefully wandering down for the presentation, is there a way to, like, kill that speaker? Is it just you? Okay, so we found the static. That's going to be interesting later. All right. So, since we've now wasted a little bit of time, sorry, welcome to everyone who is joining us here, and also welcome to everyone who's joining us online. Because that's right, we do live stream these presentations to both Twitch and YouTube. So if you're ever wondering what to do on a rainy Saturday night where you don't want to go outside, but you want to see something interesting, do check us out there and say hi in chat. You can also check us out on our website, uacnj.org. It's where you're going to find a list of all our upcoming talks and information on all our member clubs. Because we are actually a club made up of other clubs. One of the easiest ways to get into astronomy is to find your local club and join it. Not only are they local to you, easy to get to, but they're also going to have tips and tricks for viewing stuff in the night sky. That might be more relevant to you because I don't know about you. I've lived most of my life out here in Warren County, New Jersey. My tips and tricks for viewing stuff out here are going to be less than ideal and less than useful for people living in New York City. We do have a couple of clubs who are in New York City, so do check them out. In addition, you can check us out on our social media pages, Facebook, Instagram. We do have a Discord server. That's where you're going to find us post all sorts of interesting things about what we're up to and what our presentations are. So, since you're not here to listen to me ramble on forever, I'm going to get through the safety briefing real quick. If anyone here needs to use the restroom, that is the porta potty in the back. It's to my left, your right. It's big, it's blue, it's illuminated by red in the night for ease of finding because it does get dark. Speaking of getting dark, when it does, if we're using a flashlight or cell phone light to wander around to help us navigate, I do ask those lights be pointed towards the ground because we don't need to accidentally blind people or me with the latest, greatest 100,000 lumen monstrosity from Amazon. That being said, we do definitely want you using headlights when you leave because being run over is no fun. 0 out of 10 would not recommend. Let's avoid that paperwork tonight. We also have a little museum and gift shop area. Feel free to check that out. One of my fellow volunteers is in there manning that station. And assuming the sky has smiled down upon us and that the skies remained clear, please remain clear. We will also have stargazing after this presentation. Each of those sheds there has a roll-off roof. The ones with the roof rolled off have a telescope and a volunteer ready to answer all your questions. With that, we're going to get into tonight's presentation, which is about the life, the legacy of Charles Messier, given by Bill Murray. Bill is an amateur astronomer for more than 50 years. Blah, blah, blah. My tongue got wrapped around my eye cheeks, couldn't see where I was speaking. He was employed as a software engineer in the electron optics division of David Sarnoff Research Center in Princeton for 18 years. And more recently, he has taught high school mathematics and physics at Trenton Catholic Academy in Hamilton, New Jersey, and is currently employed as a planetarium technician at the New Jersey State Museum Planetarium in Trenton, New Jersey. A member of AAAP for many years, Bill has held posts of observatory chairman, secretary, program chairman, assistant director, and director in that club, one of our member clubs. He has been a volunteer observer here at UACNJ since 2014. And with that, I'm actually going to have you use this because I'm assuming that. Oh, because I should be hearing you through there. No, it's trying to find signal. So you're going to use that. I'm going to take that. The channel got changed.
Thank you, Kim. So my resume actually is updated. I'm now retired, so I have a lot more time to do astronomy. But I do work part-time still at the New Jersey State Museum Planetarium, which is a job that I loved when I was there full-time, and now I get to enjoy it part-time. So the talk this evening is about the life and legacy of Charles Messier. So hopefully the skies will remain clear, and you'll be able to go out tonight and look through some of the telescopes that are here. We may have some members who set up their telescopes as well. And so when you go to a place like this to look through telescopes, what are some of the things that you're looking at? Well, you could look at the moon. Most people do. It's very bright and easy to find, and it's very fascinating to look at. Unfortunately, the moon isn't out tonight. It's in the morning skies, so no moon. You can look at the planets. We do have a couple of bright planets visible this evening. Venus is going to be low in the west, probably too low to see by the time it gets dark enough to see it, but Jupiter will be up. So you'll get a chance to look at Jupiter through our telescope, which is another fascinating thing to look at. And those are really the only two bright planets visible in the evening skies. Saturn and Mars are visible just before dawn. So what else is there to look at in the night skies? Well, if you go to some of these guys in the observatories, they may start showing you some dim fuzzy spots through our telescope that look something like this, with names like M13, M57, M51. All of those are named after Charles Messier. And so who was this guy Messier, and why is his life and work so important to astronomers today? So Messier was born in June 26, 1730, in Badonville, France, making him a contemporary of George Washington and Benjamin Franklin. He showed an early interest in science, and he ended up being tutored at home by his older brother in mathematics and science. And his interest in astronomy was sparked by him seeing, when he was 14 years old, the great comet of 1744. This is a drawing of what that comet looked like. It must have been absolutely spectacular. It came within 0.2 astronomical units of the sun, less than 1,000,000 miles at its perihelion, and had 6 tails. It was generally regarded as the 6th brightest comet in recorded history, and it was visible in the daytime sky. This drawing is taken just after sunset, and so you can see the head of the comet is already set, but its 6 tails are visible. And so I can easily imagine that seeing something like this in the night sky would be very memorable. And Messier got an early interest in astronomy from this, as well as an interest in comets, which affected his later life. His brother, when he was old enough, obtained a position for him as an apprentice to Joseph Nicolas de Leslie, 1688 to 1768, who was the astronomer for the French Navy. And de Leslie established an observatory in the Hôtel de Cluny in Paris. And they observed from the roofs of the hotels back then were flat, so they would set up telescopes on the roofs to observe over the Paris skyline. Here's a picture of that hotel. And so when Messier was working for de Leslie, what was the main topic of interest, not only for him, and other French astronomers, but for generally astronomers, professional astronomers, and amateur astronomers, what kind of things were they looking at in the 18th century? And the answer to that, to a very large extent, is comets. Okay, so the search for comets in the 18th century was virtually an obsession with virtually all astronomers, and I'll explain why in a minute. It was a very big deal, not only in scientific circles, but in general cultural circles as well. So this is a political cartoon from the early 1800s that kind of demonstrates that. What's shown here is a picture of John Bull, who is an idealization of Great Britain in much the same way that Uncle Sam is an idealization of the United States. And he's shown looking through a telescope, and he says, aye, Master Comet, you may attempt your perihelions or your devolutions for all I care, but take my word for it, the word of an old man, you'll never reach the sun. The sun being King George III, and the comet that he's dissing is Napoleon, who was the main enemy of Britain. And what's preventing Napoleon from getting to George III? The Royal Navy between them. So comets were a large topic of cultural interest in the 18th century. And why was that? Isaac Newton was a genius and polymath, born in 1642 in England. He was generally recognized as a genius at a very early age and went to Cambridge University when he was just in his teens to complete courses in mathematics and what was called natural philosophy back then, which is the science of physics. Unfortunately, England in the mid-1600s suffered through what we went through just a couple of years ago. There was a major plague, and most of the universities and other businesses shut down for a period of 2 years. So Newton, just as he was about to graduate, had to go home to the village of Woolsthorpe in the countryside of England, where there were no other physicists around, no scientists, no one for him to talk to, and he sat alone for 2 years and just thought. And in those 2 years was one of the most productive periods of science that have ever been recorded in human history. In those 2 years, Newton invented calculus all by itself. He discovered the law of universal gravitation. He developed what is now known as classical mechanics in physics, completely revised the science of optics, and as shown here, he actually invented a new type of telescope called a reflecting telescope, also known as a Newtonian telescope. And he did all of these major things and went back to college after the plagues ended and told absolutely no one about it. Yes. Okay. Okay. So I will try. So Newton did all of this, but he was a very private man and wasn't interested in publicity. So he went back to college and sat on this for almost 20 years. He didn't have a lot of friends in his life, but one of the people he did consider a friend was the astronomer Edmund Halley. And he did get along with Halley, and one day Halley had come to him with a problem that had been perplexing scientists and astronomers for several decades. And somebody finally suggested, ask Newton about it. He may know something that'll help us out. And so Halley went to Newton and he said, we've been trying to determine what kind of path an object orbiting around an object like the sun with a central force that goes as the least square. And Newton immediately answered, that path would be an ellipse. And Halley said, well, how do you know that? And Newton said, well, I figured it out a bunch of years ago and wrote something about it. And Halley said, well, can you write it down and so we can see the work? And Newton said, oh, yeah, I'll get to it, and I'll write it down for you. And Halley had to prod him a couple of times, but eventually he wrote a series of papers that described his method of universal gravitation in physics. And Halley took one look at this and says, you have to publish this. This is revolutionary. Nobody has ever seen anything like this. And so Halley went to Newton and kept on prodding him over the course of 2 years to publish what is now known as the Principia Mathematica, which is the basic founding volume of physics, the first volume of what we now know of as classical mechanics. Halley was also interested in astronomy. He was an astronomer by choice. And in 1682, a great comet appeared over England. And Halley viewed that and got interested in comets, and was talking to Newton about them. And after Newton had published his mathematical theories in the Principia, Halley used them to figure out what the orbits of comets were. And so he went to Newton for some of the calculations, but he was eventually able to calculate the orbits of comets, how flat or broad they were, what kind of angles they were with respect to the sun. And he went through historical records and was able to determine that the comets that had appeared over England in the years 1531, 1607, and the one that he saw in 1682 were all the same comet, returning once every 76 years. And he predicted that the comet would return again in the year 1758, which would be when he was about 106, so he would be already dead. And that comet is now known as Halley's Comet because he predicted its orbit. And it did appear again in 1758. We'll get to that in a minute. But what does a comet look like when you look at it through a telescope? Well, basically it looks like a small fuzzy patch, not much else. If it's just beginning to shine, it's very dim, and people will have to scan the skies. That's what astronomers were doing in the 18th century, trying to find these comets, because now, have you ever heard the phrase, if the only tool you have is a hammer, everything looks like a nail? That's kind of the situation that astronomers were in the 18th century. They understood comets. They understood now that they were small icy bodies that were orbiting around the sun in these long elliptical orbits, as shown here. Okay, this is actually the orbit of Halley's Comet. You can see that most of the planets have orbits that are mostly circular. Halley's Comet is actually on an elongated ellipse that goes around the sun and then as far out as beyond the orbit of Neptune, which hadn't been discovered at that time. So astronomers were very interested in finding new comets and in calculating their orbits. So Messier got involved in this search, and he became very diligent in searching out comets. He would take his small telescopes, and all the professional astronomers just used very small telescopes back then. They didn't have anything really large that was good quality that they could use, and would scan the skies from the roof of the Hotel de Cluny in Paris, looking for comets every clear night. And as the year 1758 approached, many astronomers throughout Europe were scanning the skies. They wanted to be the first to recover Halley's Comet, should it return, because that would have been a major scientific achievement to see that a comet that had been predicted to return. No other comet had ever been predicted to return like that. And it would have been a major confirmation of Newton's theory of physics. So it also became a point of national pride. Astronomers all over Europe were going through the same search. And Messier was determined that he would be the first to recover the comet for the glory of France. Unfortunately, he was relying on positions for the calculated by de Leslie, who made an error. And so de Leslie's positions were wrong, and Messier was looking in the wrong spot. But eventually, he realized the mistake. And this is from his diary. So he said, the whole day, which was January 21st, 1758, was very fine and without cloud. In the evening, I went over the sky with a telescope, keeping the limits of the two ovals drawn by de Leslie on the celestial chart, which was my guide. About 6 o'clock, I discovered a faint glow resembling that of the comet I had observed the previous year. It was the comet itself, Halley's Comet, appearing 52 days before perihelion. Unfortunately, he wasn't the first to see it. He had been beaten to the punch by a German amateur astronomer, Johann Georg Pallisch, who had recovered Halley's Comet on Christmas Day in 1757. Score one for amateur astronomers. But Messier was not deterred. He was determined to find as many comets as he can. He spent many nights observing the skies, trying to discover comets. He discovered 21 comets, 14 of which he was the first person to see. and he was one of the major comet discoverers of the 18th century. He found so many comets that he was awarded a medal by King Louis XV of France for his many discoveries, and the king called him the ferret of comets because he was so good at hunting them out. Some of the comets that Messier found. The Great Comet of 1769. It was discovered by Messier on August 8th, 1769. It reached magnitude 0, very bright for a comet, and had a 60-degree long tail, almost a sixth of the sky, so very bright and very large. Was observed throughout the world, and at that time, comets were generally regarded as portents of disaster and bad luck, and it was noted many years later that 1769 also happened to be the year that Napoleon Bonaparte was born. And so that came back to Messier in a rather good way later in his life. Another comet that he discovered was called Lexell's Comet, discovered by Messier on June 14, 1770. Its orbit was computed by the astronomer Anders Lexell. That's why it has his name and not Messier's name. The comet holds the record for the closest approach to Earth by any comet, only 1.4 million miles. So about 7-8 times the distance from the Earth to the moon. That's how close the comet came. And it became the first lost comet. It was recorded several times later, but then it disappeared and was never seen again. And astronomers postulated that it had too close passes to the planet Jupiter and was ejected from the solar system. So some of the problems that Messier encountered during his search for comets. He would occasionally find in his telescopes small fuzzy patches in the night sky that looked a lot like comets, but they weren't, because comets over time move across the sky and eventually disappear as they orbit around the sun. These objects he was finding were located in the same position from night to night and from week to week and month to month and didn't move at all. And so they were interfering with his comet searches because he would have to watch them and observe them to see that they weren't moving. And as he was doing that, he could have been searching for other comets if he knew they weren't comets. These objects had a name. Scientists called them the nebula. Nebula in Latin means cloudy or cloud. And they had been known for centuries, but no one knew what they were. That seems to be a thing with astronomers. Just because you don't know what something is doesn't mean that you can't give it a name and see how it works. The current favorites for that are dark matter and dark energy, which scientists still don't know what they are, but they have names anyway. In the 18th century, nebula was something that they could see, but they didn't understand. This is kind of a picture of what nebulae look like in a small telescope. They're usually grayish because the human eye has a lot of trouble seeing color at low light levels. And they look like basically little cloudy patches in the night sky. And as I said, these objects remained in the same position. They didn't move. They looked a lot like comets. And so eventually, Messier got a little bit irritated finding them. And after he discovered one of these, which now has the name M1, the first object on Messier's list, and we'll talk about that in a minute, he entered this into his diary. What caused me to undertake the catalog of nebula was the nebula I discovered above the southern horn of Taurus on September 12, 1758, while observing the comet of that year. This nebula had such a resemblance to a comet in its form and brightness that I endeavored to find others so that astronomers would not confuse these same nebula with comets just beginning to shine. I observed further with the proper refractors for the search for comets, and for this purpose I had in forming a catalog. His idea was he would save future comet hunters the trouble of locating these objects and then thinking they were comets by finding them, locating their positions, and publishing them in scientific journals. And so that began what was known as the Messier catalog. The astronomers of that time used very small telescopes. The technology to build telescopes was not very advanced in the 18th century. Small refractors were generally what was mainly used for scientific research. Reflecting telescopes, like the one that Newton had invented, had not been perfected yet and had a lot of technical difficulties with using them. So astronomers used these small telescopes. Basically, the scientific uses for these telescopes that astronomers were using back then Um, the telescopes weren't really better than what you can buy in like a cheap, less than $100 telescope today. So the telescopes that amateur astronomers use were much better than the ones that professional astronomers were using in the 18th century. This is kind of what some of those objects looked like through those telescopes. They had various shapes and forms. They all appeared to be some variation in cloudy little patches. None of the astronomers realized what they were, but Messier decided to create a list of them anyway. And over the many years that he spent searching for comets, working with a younger colleague, eventually, named Pierre Messier, they completed a list of 45 of these nebulous objects and presented them to the French Academy in 1774. By 1784, Messier and Messier had found a total of 103 objects. The list was published in the French scientific journal Connaissance des Temps that year. And modern versions of the Messier catalog contain 110 objects that were observed by either Messier or Messier. And this is the first page of Messier's original catalog with the date that objects was discovered, September 1st, 1758, number, and then the description of that object, what it looked like, nebula discovered over the southern horn of Taurus. That's M1, the first object on Messier's list. Messier went through a lot of trial and tribulation in his life. During the French Revolution, the Reign of Terror from 1793 to 1794, the French Academy, which was generally regarded as an aristocratic institution, was dissolved, and both Messier and Messier lost their jobs, but kept their heads. They weren't executed, at least. But Messier still continued his comet searches during that time, and he discovered a new one on September 27, 1793. Eventually, when Napoleon came to power in the late 1790s, the Academy was reestablished, and both Messier and Messier were readmitted. Messier became the new director of the Paris Observatory, and in 1806, Messier was awarded the Cross of the Legion of Honor by Napoleon himself for his many comet discoveries. Napoleon might have remembered that Messier had discovered the comet that heralded his birth in 1769. So Messier got awards from both the Royal King of France as well as Napoleon. His eyesight began to fail in his 80s, and in 1807 he ended his career as an observational astronomer, and he died April 12th, 1817 at the age of 86. And he was buried in the Père Lachaise Cemetery in Paris, which is a very famous cemetery. There are a lot of very famous artists and scientists and intellectuals buried there. Americans generally recognize it as the place where Jim Morrison of the Doors was buried. And for many years, Messier's grave was lost, but eventually was found, kind of in an odd little location in the corner somewhere, not very well kept up. It's now being restored by the French astronomical community. So hopefully it will look a lot better than this over the coming years. So what is the legacy of Charles Messier life? Well, we have the Messier catalog, 110 objects, M1 to M110. The irony is that nobody today really remembers any of the comets that Messier found. They remember him for this list of what he called embarrassing or unfortunate objects, the brightest deep sky objects visible in small telescopes in the northern hemisphere. So what are some of these objects? Well, generally they fall into several classes. They can either be diffuse or gaseous nebula, open clusters, supernova remnants, globular clusters, asterisms, or galaxies. And there are a few mistakes as well. So let's take a look at some of those objects. Some we may be looking at tonight if the weather holds up. So this is a picture of the life cycle of stars. Stars are all born in what are called gaseous nebula, stellar nebula here. These are clouds of gas and dust, mainly hydrogen gas. And a star's life is dependent upon how much mass it has originally. So smaller stars like our sun, an average star, are born out of these clouds. When part of the cloud becomes a little bit denser than other areas of the cloud, it begins to contract. And as it contracts, its gravity increases and it begins to pull in more gas and dust from other areas of the cloud. When that happens, eventually these areas of condensation become so hot and dense that nuclear reactions start and stars are born. A star like our sun, which is a relatively small star, will live its life in burning hydrogen gas for 10 to 20 billion years, eventually run out of hydrogen gas and start burning other elements and puff up into a red giant star. Eventually, that process makes the star unstable and it begins to pulsate and throw off most of its remaining gas and dust into an expanding cloud, and the star becomes a planetary nebula. And then after that, when the gas dissipates, the only thing left is the dead core of the star, known as a white dwarf. Stars that are much more massive than the sun, maybe 10 times more massive than the sun, end their lives very differently. They burn very fast, so stars like our sun can live for 10 to 20 billion years. Massive stars only live for a few 100 million years at maximum, burning through all their hydrogen very quickly, expanding into a red supergiant and ending their lives as a massive explosion called a supernova that results in either, depending on the mass of the original star, if it was somewhat less, what will be left after that explosion is a neutron star, and if it was greater, you end up with a black hole. And so many of the objects on Messier's list detail this process of a star's life. So this is a drawing of M17, the Swan Nebula, 17th object on Messier's list. It was observed by Messier in June of 1764. He wrote of it as a streak of light without stars, spindle-shaped. It's one of the brightest gaseous nebulas in the northern sky. It's about 5,000 to 6,000 light years distant. And this is an image that was taken of that. So this is one of these gas clouds where stars are being born. Which leads to the question, why don't nebulas look like the pictures we see in magazines? And the reason is the human eye is very insensitive to light at low light levels. So if, for instance, you take a magazine with a lot of colorful pictures in it, that you can see all the color very easily in the daytime into a dark room, the pictures look all grayed out. And you still may be able to read the text in the magazine, but the pictures don't look like they have any color in them. And the reason for that is your eye is it's very difficult for your eye to pick up color at low light levels. So the pictures that you see, like this one here, which do pick up those colors, are taken through telescopes with very sensitive cameras, sometimes for hours, sometimes actually for days. So astrophotography is not just snapshot photography. Many of the pictures that you see were done over many hours of exposing the same object. This is another picture of a gaseous nebula. We can see here the clouds where the stars are being born. These little nodule areas are actually baby stars that are just about to be born. So what happens is when stars begin to shine under their own light, their radiation dissipates a lot of the remaining gas. So we can see here these very hot young stars are blowing away all of the remaining gas. The reason why they haven't blown away these areas yet is because there's a star inside there that's just about ready to be born that's holding the remaining gas there. This is a picture of M42, 42nd objects on Messier's list, the Great Nebula in Orion. This is what it looks like through a telescope, a kind of grayed out gas area. This is a picture of the same object. This is a close-up picture of the Orion Nebula. The stars right in the center here are a very famous multiple star system called the Trapezium, also Theta Orionis. Those stars are very young. Several of them are only about 10,000 years old. That sounds old to us as human beings. We'll only live a century or so. But stars can live for billions of years. So a star that's only 10,000 years old isn't even out of the celestial maternity ward yet. So this is M11, the wild duck cluster. Messier observed this in May of 1764. He wrote of it as a cluster of faint stars, which may only be seen in good instruments. It's about 5,500 light years distant. This is an open cluster. So stars are born out of these gas clouds, and when they begin to shine, their radiation dissipates all the remaining gas. When all of the gas is gone, what you're left with is a cluster of several dozen to several hundred very young stars, and that's what we're seeing here. So the process looks something like this. We have stars in a gas cloud that are being born. Eventually the gas dissipates, and we're left with a cluster of young stars. And as clusters age, the stars get older and begin to change color. Young stars tend to be blue. Older stars can be yellow, red, blue, any other colors as well. So Messier discovered objects on his list that not only reflect star birth, but star death. So this is the 57th object on Messier's list, known as the Ring Nebula. It was observed by Messier in January 1779. He described it as a patch of light between the stars Lambda and Beta Lyrae, which has rounded borders and must be composed of very faint stars. That's not true. It's actually made of gas. It's about 1,140 light years distant. So this is what's known as a planetary nebula. So this is a star like our sun that's dying. And as I said, when stars like our sun get old, they've used up all their hydrogen fuel, and they become unstable and begin to pulsate and throw off most of the remaining gas that they have into an expanding gas cloud called a planetary nebula. And here's that shown here. This is the core of the star that's left. Planetary nebula actually don't have anything to do with planets. The name comes from the English astronomer William Herschel, one of my favorite people in astronomy. He had been the person who had discovered the planet Uranus in the 1780s. And when he was surveying the sky for nebulous objects, which was one of the things that he did as a professional astronomer, he saw these objects and they looked to him like very faint versions of the planet Uranus. So he named them planetary nebula without knowing what they were. Actually have nothing to do with planets at all. But here's another example of astronomers giving a name to something that they didn't understand. Then we have the first object on Messier's list, M1, the Crab Nebula, discovered by Messier in September of 1758 in the constellation Taurus. It's about 6,500 light years distant. This is a picture of M1, and you can see here in this image the tendrils of gas that gave it the name Crab Nebula, which was given to it by the English astronomer Lord Rosse in the 19th century. Of all of the objects on Messier's list, and indeed many of the objects that we can see in the night sky, this is one of the few where we actually know its history and its story. So in the year 1054, Chinese astronomers recorded what they called a guest star. A new star appeared in the sky. It was very bright. It was actually brighter than the planet Venus and was bright enough to be visible in the daytime sky for 23 days. The location of this star is exactly where M1 is today. So this is a supernova. It was not recorded, as far as we know, by any astronomers in Europe at that time, but it was recorded here in the New World. So these are some examples of pictographs in the American Southwest by Native American tribes, the Anasazi and other tribes that were in that area at that time. And astronomers and archaeologists now believe that these pictographs represent the explosion of the Crab Nebula supernova. This is an image of what it would have looked like on the morning of July 5th, 1054, above the horizon in southwestern United States, drawn by astronomers who figured out what the sky looked like after the event. We also have globular clusters. This is M15, 15th object on Messier's list in the constellation of Pegasus. It was observed by Messier in 1764. He described it as a nebula without star between the head of Pegasus and that of Equuleus, the small horse. It is circular and bright and is 30,600 light years distant. And this is an image of M15. So as opposed to open clusters, which are clusters of several dozen to several hundred very young stars, these globular clusters are anywhere from 200,000 to 1 million very ancient stars, some of the oldest stars we know of in the universe. The universe is now thought to be about 13.8 billion years old. Many of these stars are 13 billion years old, so almost as old as the universe. So astronomers are left with the question, well, if they're only 800 million years younger than the universe itself, how did these structures form early in the universe? And that is not quite known yet. Messier also made some mistakes when he was observing the night sky. So this is the 73rd object on Messier's list. It was observed by him in October 1780. A cluster of 3 or 4 faint stars, which at first glance resembles a nebula and does contain some nebulosity. We now know that that's not correct. There is no nebulosity in this object. It's about 2,500 light years distant, and it's not a true cluster. It's only a chance alignment of stars. And this is a picture of M73. We also have what is probably the largest number of objects on Messier's list, galaxies. So this is a drawing of M31, the Great Nebula, or the Great Galaxy in Andromeda. This object is bright enough that if you get to dark skies, you don't even need a telescope to see it. You can see it with your unaided eye. It was noted by the Persian astronomer Al-Sufi in the 10th century, and it was observed by Messier in August of 1764. The astronomer Simon Marius likened M31 in 1609 to the light of a candle shining through horn. Still a pretty accurate description of what it looks like in telescopes today. Here is a modern image of what M31 was. So, unlike all of the other Messier objects which we've talked about, and all of those objects are in our galaxy, the Milky Way, these other objects are completely different galaxies outside our Milky Way. For instance, M31, that label is actually wrong. It should be M31, is about 2.5 million light years away. And in this drawing, you can see there's actually 2 satellite galaxies that also were observed by Messier, M32 and M110, very close to the Andromeda galaxy. It wasn't realized that galaxies were separate star systems until the 20th century, when the American astronomer Edwin Hubble used the 100-inch telescope at Mount Wilson, California, to identify individual stars in these galaxies. And by measuring the brightness of these stars, he was able to determine that they were millions of light years away, much farther than any object in the Milky Way. So those are some of the objects that we may be looking at tonight, if it stays clear, on Messier's list. So what is Messier's legacy after all these 250 years? Well, there's comets. He does have the reputation of being one of the great comet discoverers of history. Unfortunately, we don't see a lot of great comets these days, but these are 2 that were visible in my lifetime. This is Comet Yakutaki, which graced our skies here, I believe, in 1997. Very green comet, green even to the unaided eye, and the brightest comet that we've ever seen here in the northern hemisphere in my lifetime. This is Comet Hale-Bopp, which appeared just a year later in 1998. We have the Messier list. So here is all of the 110 objects on Messier's list. They're all visible in small amateur telescopes to varying degrees. And if you feel a little bit masochistic, you can even endure a Messier marathon. So it just so happens that at one point in the year, which happens to be just about the time of the spring solstice on March 21st, the sun is located at a position in the sky that it's just barely possible in a single night to see every one of the 110 objects on Messier's list. So astronomers come up to dark areas like this in March or early April, wait for the night of the new moon when no moon is visible, and start observing Messier objects as soon as the sun goes down and continue right until the sun comes up. It's very difficult to complete because some of those objects are barely visible before they set just after sunset, or barely visible just before the sun rises. I've done several Messier marathons up here at Jenny Jump. My best record so far is 102 of the 110 objects on Messier's list. Very tough to do visually. Here are some references if you're interested in learning more about Messier and the objects on his list. The book on the left, Burnham's Celestial Handbook, is a little bit getting long in the tooth. It was published in the 1970s, but it's still one of the best general guides for observing objects in the night sky. And Burnham goes through a large and very detailed description of every Messier object on Messier's list. Second book is more modern, by Stephen James O'Meara, The Messier Objects. He's one of the great visual observers of our time, and he observes and draws all of Messier objects with relatively small telescopes. And the last one, by Harvard Pennington, is a year-round guide to the Messier Marathon. If you're interested in trying a Messier Marathon, that's a good book to have with you. So that's my talk this evening. Thank you for attending. Feel free to ask any questions that you have, and I'd be happy to try to answer them. Thank you.
All right. Thank you, Bill, for another great presentation. So, for how question and answer session is going to work, for people here, you're going to raise your hand and wave it about and keep your hand up, because once you put your hand down, you're just kind of shadowy figures in the dark, and I have no night vision since I've been staring at a screen. Online people, you have it easy. You can just type into the chat. And do get those questions in, just so we don't miss you. All right, so I'm going to start us off with the first online question, which is, how does color blindness or sensitivity, like how they're finding some people have an extra type of, like that cone or rod situation, and they have extra colors, affect visual astronomy, or does it not?
I have not read anything or heard anything about color blindness affecting the ability to see nebulous. If you have more color sensors in your eyes, you might actually be able to detect colors that other people can't.
Yeah, I don't know, but that would be a fun bit of science to do for someone. Okay, we need a couple like 8th grade science class, and that's what your science fair project's going to be. All right, any questions out here? All right.
You mentioned that the great comets aren't as common anymore. Why is that?
It's just chance. Comets, we do get a fair number of comets through every year. Most of them are fairly dim, 8th or 9th, 10th magnitude. So they're visible in small telescopes, but not visible to the unaided eye. It tends to be pretty rare that you see comets that are bright enough to be visible to the unaided eye. The two that I mentioned are two that I remember. When I was very young, in my about 5 or 6 years old, there was a comet called Ikaea Secchi, which was another great comet back in the early 1960s.
It sounds like a piece of furniture you get from IKEA.
But other than that, we haven't had a lot of really bright comets. It might have something to do with light pollution too, wiping out a lot of the lesser comets. But it seems like that back in the 17th, 18th century, that a lot more of these bright comets were visible. And maybe that because people didn't have light pollution back then, they were able to see them better.
All right, our next online question. If we know things are incorrectly named, such as planetary nebula, why don't we rename them? Or is it a if it ain't broke, we ain't gonna fix it situation?
Well, I think it's more like it is broke, but nobody's bothered to fix it yet. And basically, it's just inertia. These things got named several hundred years ago. Astronomers have been using those names for hundreds of years.
And we know what it is, so.
And nobody really has any desire to change it anymore.
All right. Anything else?
Okay.
What's
a good
the
question.
difference between the Messier catalog and the NGC catalog? Just so our online people can also hear.
So that's an excellent question. So Messier was not looking for deep sky objects. He was looking for comets. And he was using very small telescopes. So his catalog is basically comet rejects that he found over the course of his life. There are only 110 objects on the list, but they tend to be the brighter ones because he wasn't looking for them and was looking for them only with small telescopes. The NGC catalog was actually originated by the astronomer William Herschel, who I mentioned once in my talk. He was one of the few astronomers in the 18th century to use reflecting telescopes. He became a master at making telescopes, and 3 times during his life, he made the largest telescope in the world. The final telescope that he made had a diameter of 6 feet. So he had a huge advantage over finding faint objects in the night sky over other astronomers who were using small refractors. And his interest was actually to trying to discover all of these little nebulous objects that could be visible in the telescopes of that size. He found quite a bit more of them. In his lifetime, he discovered about 2,500 of these nebulous objects that weren't on the Messier list. His son, who followed him, was also an astronomer, took his telescopes to the southern hemisphere and discovered several more thousand objects in the skies over South Africa. And eventually other astronomers continued the search in the 19th century, and there was an astronomer called J.L.E. Dyer about the year 1880, who took all of these discoveries made by John Herschel and William Herschel and other astronomers and compiled them into one catalog, the New General Catalog, or NGC. So there are about 8,000 objects in that catalog. Tend to be not as bright because they're much dimmer. They were found with larger telescopes. But after people like me complete the Messier catalog and observe all the Messier objects, the next challenge is starting to observe all the objects that the Herschels observed on the NGC. And that's something that'll probably take my entire lifetime.
I was like, that's not a one night.
No.
That's not a one night marathon. That's going to take some years, because I have to go, south of the equator. Right. Any more questions out here? Right. Online people, if you have any last minute questions, do get those in. I like to give them a little forewarning, because by the time they've heard that, we're already a couple minutes into the future, because that's how stream delay works. So in the meantime, thank you, Bill, for another great talk. Thank you, everyone, for joining us.
And hopefully we'll be able to see some Messier objects tonight. It's clear.
Hopefully. Just a couple reminders. If you need to use the bathroom, that is the porta potty in back. It is illuminated by red for ease of finding in the dark. As we're wandering around, it is dark. If we have any flashlights, do try and keep those pointed towards the ground. That being said, we are using our headlights when we leave because getting run over is no fun. Let's avoid playing Frogger in real life. We do have a little museum and gift shop area. Do feel free to go in there, check out our meteorite display and other fun stuff. And we do have a couple of observatory open. I don't know what we can see. And I don't know whether it's just my eyes or there's a fog rolling in. It could just be my eyes, so I'm not going to be too concerned about that. With that, it looks like our online questions are done. So thank you all. And until next time, come visit us Saturdays, April through October here in Jenny Jump State Park. And until next time, good skies, clear skies, and good seeing.